I know you had a brief introduction to AI Leaf and the program last week. I'm excited I get to be the first speaker to kick off the content part of this. And so I wanted to give you a background on climate change, climate impacts to agriculture, and then this concept of climate smart agriculture, which was really the foundation for why our AI Leaf Institute was founded. And then I want to talk about some of the tools we have developed at Cornell that actually help farmers to understand climate impacts on their farms. And I'll go live to those so we can kind of use them. And then for the computer scientists on the call, those tools don't right now do not incorporate AI. And so what we're hoping to do over time is use your brain power, use the brains of our amazing computer scientists with AI Leaf, and really work to integrate AI into tools like those so that they're even more powerful. And so with that, let me get started. So this is just a little bit about me. I am an environmental social scientist. I got my PhD at the University of Maryland. I think you'll see from the wide range of folks that come and speak to you, we all have really different backgrounds, but we can all work in this space, which is really exciting. So I have been here at Cornell since 2013 and really started working here on climate change in agriculture. And I've gotten the opportunity to work in that space internationally. So there is a huge focus on climate smart agriculture globally. And I've been going to the climate negotiations for the Paris Agreement for about 10 years and working on climate change and agriculture negotiations there. So this is a really important issue. And what my research focus is on, and I get to work with Candace Hulbert on that and others at Cornell, is how can we ensure that farmers understand climate change impacts and that they have the data, tools, and resources they need to adapt and mitigate. So today I want to just introduce you to climate change, then talk about impacts to agriculture, climate smart agriculture, introduce some of these climate smart farming tools, then look at how AI could take those even further. And I realize from your introductions that we do have a vast group with different expertise here. So some of this may be really basic for you, but for some of you, this may be the first time you've heard it. So I do apologize if I'm giving you a little bit of an overview, but I want to make sure we're all on the same page starting this program. So I want to start by having you watch this visualization, which I often have my students watch. And when I go out and talk to farmers, I have them watch it. So I'd like you to just watch it quietly and maybe look at a place on the map that you're from or a place you've visited around the world and see how the climate has changed. So seeing this, it's data from NASA, and we say that this is observed data. This is real data that shows how the climate has already changed between 1880 to 2024. And you can see the red is lighting up. Almost everywhere on the planet is getting warmer. 2024 and the decade in the past has been the warmest decade ever recorded. And so this is a huge challenge. We know that climate change is going to continue. Our planet is going to keep warming. And so, and a whole lot of other effects that I'm going to talk about. So we need to help agriculture to respond to this, both to help farmers adapt and to help reduce the emissions that are contributing to this change. Okay, so I want you to think about it. That shows you kind of a global view, but I also want to think about how climate change is affecting your community. Have you seen the changes over the last 30 years, maybe in your lifetime, the last 20 years of a community you live in? This is a community in New York State, Oneida, New York, where there's been some massive flooding lately. This shows the Oneida River flooding, and I'll talk about some of those changes. So climate change is not something that's far away. It's happening in our country more and more. We see the impacts. And farmers are noticing this. This is a wonderful quote from a farmer. He has about 1,000 acres of organic grain. He actually went to Cornell University, and he is a technician, a technology expert. He fixes all his own tractors, and he says that there is not a normal season anymore. It's either really dry or really wet. When we get rain, it's apocalyptic. We got 5 inches of rain in about an hour and a half, and that caused a lot of soil loss on his farm. So I want to ask you to think about, how has the climate already changed? And by this, we're talking about, again, the data that we have on record. And so we can see here, this data comes from the last climate assessment for the United States. The link is down there. The US has warmed dramatically from 1895 to 2015. And we've seen that, you can see here that it's statistically significant warming throughout the United States. Um, This next graph shows the change in precipitation across the United States, and we've seen that there's been an increase of about at a rate of about 0.18 inches, or almost 0.2 inches per decade. So if you add that up over 100 years, it's a lot of increase in rainfall, which we don't often think about. But some of our areas of the country, Colorado, where some of you are actually seeing a decrease in precipitation. Some of us up here in the Northeast at Cornell or Delaware, we're seeing an increase in precipitation. And the way that we see that rainfall falling is very different. So we know that climate change is causing an increase in temperature. When there's an increase in temperature in the atmosphere holds more water. And so it holds onto that water. And then when it does rain, it's more heavy precipitation events that are causing intense rainfall. So this shows that everywhere in the United States, except Hawaii, has seen an increase in these intense rainfall events. The Northeast has seen the greatest amount of this increase. And we know this is causing a lot of damage. This is the increase in by state from billion-dollar disasters from 2018 to 2022. You can see everywhere is experiencing these impacts. Cause a lot of damage to infrastructure, to communities, to bridges and farms. And we also see a change in drought. This data is from, again, the EPA's climate indicators. If you're interested, you can go to that link. And it shows that drought conditions across the US 48 contiguous states have changed from 1900 to 2023. Blue areas represent increased moisture. Brown areas represent decreased moisture or drought, which might make you think the drought is only occurring in the southeast. This is showing extreme drought, but actually short-term drought happens everywhere, even in New York State. This shows you today. A wonderful data source for you is the Drought Monitor at the University of Nebraska. And even in New York State right now, definitely in Vermont, there's extreme drought. So you may ask, like, how is that happening? Well, if you think about it, more of our rain is happening in these extreme rainfall events. And in between there, the rain is not happening, the precipitation. And so there's increased temperature. We see more evapotranspiration. and more likelihood of short-term drought. So that was all how the changes have already occurred. What do we see for the future? This data comes from the Intergovernmental Panel on Climate Change. And what you can see here is patterns of change in near surface air temperature, precipitation, and soil moisture, how they might change in the future based on the degree of greenhouse gases that we all put in the atmosphere. So if we put more greenhouse gases in the atmosphere, the change is going to be greater in temperature. Same with precipitation and same with soil moisture. You can find more data on future projections at the IPCC. And this shows what this would feel like if we have 2 degrees Celsius of global warming in the United States. It's going to vastly change our climate. In the Northeast, the minimum summer temperatures are going to increase by an additional 3.2 degrees Fahrenheit warming. It's going to cause a lot of changes in the future. This data comes from the 5th National Climate Assessment for the United States, and it shows that potential warming pathways, if you can see my cursor here, the more greenhouse gases we all emit, we're going to have very high warming by 2095. And if we reduce emissions, we're going to have less warming. So this is our goal. Should be our goal with the Paris Agreement, is that every country should be reducing our emissions so that globally our temperatures don't increase so drastically. So I want to turn to how climate is affecting farms, and basically a really tight snapshot in one slide. We already see changes with higher temperatures and heat waves. It's causing short-term drought that affects crops and causes heat stress for animals. We see an increase in heat waves that causes a lot of stress for, again, for crops and animals. That affects milk production in dairy cows. It causes them to have less fertility. For crops, we see this effect of extreme rainfall or snowfall actually affects fields. This is a field in New York State that was flooded and causing a lot of soil erosion, as Tor Oshner talked about. We also see changes in pests and disease, where these ranges for pests and disease are changing. So we see new pests that are able to flourish higher in New York State or in different parts of the country. And what farmers talk about a lot is that there's increased variability and uncertainty. So the way that they would have farmed when the climate was more stable, when their grandparents were farming, that doesn't exist anymore. And one season can be really different than the next season. There can be a season where it's incredibly cold and wet, as it was here in the Northeast, and it makes it extremely difficult to take your tractors on the farm and to plant. And this year in New York State, farmers just could not get in and plant their corn that feeds their cows. And we say here in the Northeast, we should have corn that's knee high by the 4th of July. If you drove around this area, the corn was nowhere near that. And so that affects farms in a lot of ways. They often have to buy feed for their cows, and it affects their bottom line. So what's causing this climate change? This is really brief for you guys. You know that we have a natural greenhouse effect where solar radiation is coming in from the sun. And when we increase these greenhouse gases, they're acting like a blanket and less heat is able to escape into space. The only place that has to go with this energy, it can't escape. The heat is solar radiation is coming in. The only thing it can do in terms of physics is to cause an increase in temperature. And that is causing all these other cascading impacts. So we're basically taking carbon that was stored in our lithosphere for thousands, millions of years, and we're taking it and emitting it up into the atmosphere where it doesn't belong. And then it's hopefully going to be brought back down. Right now, the ocean is our largest carbon sink, which is fortunate for us. We can also sequester carbon in the soil and in trees, which is a large part of what many of you in agricultural science are working in our department. We work with our professor Johannes Lehmann with the AI-leaf Institute, really to study how can we sequester more carbon in the soil. So where are these greenhouse gases coming from? You can see most of it is carbon. Then there is nitrous oxide, and that's N2O, and then CH4, and then a small part of these are these hydrofluorocarbons that are man-made gases. And agriculture contributes a lot. It's 10% of overall emissions. So we need to help agriculture reduce those emissions. So this just talks about how climate change is already disrupting ag systems, and these impacts are distributed unevenly, with farm workers, communities, and rural populations facing increased risks. A lot of rural farms are already struggling to make a profit, and when climate change impacts them, it's just another hit, and they don't have the resources to adapt and mitigate. So that's one thing that we need to help them with. We also need to give them information so they know how to change. There can be some opportunities with climate if we can give them really precise information, like could they plant another crop if the growing season is longer? So this is the grand challenge that we should be working on, that for agriculture, it's a triple whammy. We know that agriculture contributes to greenhouse gas emissions, but farmers are on the front lines of impacts to agriculture. It is affecting their bottom line. And at the same time, globally, we have these impacts are causing losses to crops, and we have a growing population that needs to be fed. And so how do we, at the same time, reduce emissions, but help farmers adapt and actually grow more food sustainably? So that is this concept of climate smart agriculture and these three-pronged approach. And it's not easy. This is not easy. To how do we figure out as researchers how to, again, how do we help farmers adopt practices that are going to help them be more resilient, but also reduce their emissions and increase food production? And so this is what our team has been working on at Cornell through our Climate Smart Farming program for many years. And some of the tools that we're working on are both to help mitigate and adapt. I hope you understand the difference. Many people confuse this, but when we talk about mitigation, we're talking about actions that reduce greenhouse gas emissions in the atmosphere or sequester them. And when we talk about adaptation, we're talking about adaptations to help reduce the impacts, so helping farmers to increase resiliency. And so for mitigation, there are many things that farms can do. They can conduct an energy audit or a greenhouse gas accounting audit, figure out where the emissions are, and then try to reduce them, or figure out ways that they can sequester carbon in the soil. And a great tool has been developed by Colorado State. A shout out to all of you at Colorado State. This is the Comet Farm tool, which helps farmers estimate whole farm carbon sequestration and greenhouse gas emissions on their farm, and then helps them develop a plan for reducing emissions. For adaptation in agriculture, we see a similar process to where farmers need to identify the impacts on their farms, and then there's not like a one size fits all process to make these changes. You can imagine that agriculture and ranching in Colorado or in Delaware or in New York is really different. Farms are all different sizes, their production's different, they're growing different things. So the way that they are going to be able to adapt, we have to work with them. It's very tailored to their specific operation. So what we need to do is actually help them go through a planning process. And we've actually done some of this work with our team at Cornell, working with the USDA Climate Hub, where we've trained farmers to understand the impacts on their farm and the greenhouse gas mitigation, and then develop a plan that they can actually identify the actual practices they can adopt. Like, should they start improving soil health? Should they adopt cover crops? Should they plant different crops? All of these things together to help increase the resiliency on their farm. And again, this is not easy. Candace and I can tell you that out of all the farms in the Northeast, Candace, how many do you think have undergone an adaptation plan?
Oh
Or what do
man.
you guys
Mm.
all think? What do you think? What percentage of farms do you think have done an adaptation plan on their farm? Is it like 50% or 75% of farms, or maybe 20%, 5%? What do you all think? There's no right answer. Yes.
Yeah, I would guess maybe like 10%
I was gonna
of
say less than 5% is my guess.
Mhm.
You guys are both right. I would say we don't even actually know. I mean, no one
Yeah.
has done research on that, but I would say it's probably less than 5%, maybe even less than 2%. It's really
Yeah, it's
low.
a small group of farmers.
And it's the farmers that are really understand this issue and they care and they have been hit by climate change. They're getting hit every year by extreme weather. And so maybe they're more interested in starting to do this planning process. But that's one thing we can help them with.
Would you say one of the biggest limitations is just sociological aspects, like just generational practices and things like that? I know at least here in Colorado and in other coming from like one generation removed from agriculture, I feel like that's just the biggest barrier in general. Like my uncle, he just adopted no-till last year. So it's just
Wow.
so I'm just wondering if you agree that the main driver is probably sociological.
Yeah, that's a great insight. I mean, I think it's many things. I think it's financial. And we can say that farmers lack the capacity to make these changes. And when we talk about capacity, we talk about it in terms of knowledge. They don't have the knowledge, many of them, of how the specific impacts. Um, they don't have the financial resources. They don't have the support from extension or these universities enough. They don't have enough support. And then, as you pointed out, a huge part of it is that many of them don't believe in climate change or they're skeptical. And then we know from research, Candace and I are working on writing up and Sophie is going to be a co-author on our paper. We know we did a survey of farmers in New York State. We know that many of them don't believe in climate change. And then of those that believe in climate change, they misunderstand. They don't understand that it's human caused. They think it's caused by natural causes. And we know that farmers that don't believe in climate change are not willing to make these changes because they don't understand the linkage. So that's a great point. And we would love to like get more students involved in that kind of research to understand that. So this is where our AI Leaf Institute comes in, and it's a great segue, your question, because what we're doing over here in this education workforce development is we're trying to educate farmers about climate impacts and mitigation and about how AI tools can help them. And then we're also trying to work with these other teams that are developing all this cool AI tools and help farmers use them and understand them. And this is not an easy challenge. which is why we're getting all of you, the next generation, involved. This is going to take years of work. We don't even have the tools yet. We have some of the tools, but that it's going to take a long time for these farmers to adopt the tools, to understand these changes, and then start adopting them. So this is where AI comes in, and you all know this, but AI and machine learning can help farmers with more complicated questions and make decisions based on all this different type of data that's available. One, going back to your question, oftentimes these scientists will say, oh, we're just going to develop these tools for these farmers, and then they're going to use them, and they're going to be able to understand these changes. And I would say, this is this idea, if you build it, they will come. I would say, really? Not so much. It's not like a trusted tool if it's not easy to use, if they don't have access to it, if they don't know how to use a computer, or they don't have the time, then they're not going to adopt these tools. So when we develop these tools, we need to keep this in mind, forefront of our mind, and make sure, like the African American farmers in Delaware, the smaller farmers in New York, we have to make sure that they can use these tools. And this is where we talk about, we need to talk to stakeholders. And this is the work that Candace led with me and with folks like Sophie last year. And this year is really, we've done some focus groups to talk to farmers about how they're viewing AI and tools, and are they interested in using them, and will they use them if we work with our researchers to develop them. So now I just want to maybe go live, if that's okay. So I want to show you the climate smart farming tools at Cornell. And unfortunately for you guys in Colorado, you can't use these, but you can enter any address in the Northeast and see what they show you. So can one of you, maybe the student from Delaware, can you give me an address that you want to enter in this tool?
You could type in Bombay Hook. It's a national bird refuge.
We know that because that has captured that, we can now close this link, and you can see it's calculating. It shows you that that's the location. And now if, let's just pretend this is a cornfield. And so if you would tell me when you think they would have planted corn in Delaware, would it have been around May 1st?
So yeah, I mean mid-May, I would say.
Okay. All right. So this is pretty interesting. This will show you where the growing degree day accumulation in that plant is for that exact location right now. So we are at September 11th, and it's showing you, interestingly, that this is pretty on par with the 15-year average. And many times when we look at this tool, the growing degree calculations are way above average. And maybe it's on par because we had a really colder start to the season this year. But what this also can tell you is that if you want to say your GDD target when you want to harvest this corn is that, then it will tell you that. And if you want to put the first and last frost in, it will tell you when that frost is, so that you want to definitely harvest the corn then. And then just for kicks, if you put this back to 2024, you can look at different seasons and see how that season was. Actually, this is super interesting. You see how much warmer that season was. The plant accumulated warming much faster and was up near the record high for every day in the period that's ever been recorded. Okay, so that is just one tool. And now I maybe show you a different tool, which is our water deficit calculator. I'm just going to stick with Cornell because we're running out of time, but I'm going to say that we have at Cornell on this farm, we do have farms here, that we have medium soil water capacity here, and that we are growing forages for our cattle, and that the planting bud break for those probably was around May 15th this year. And if you see where we are right now, September 11th, there's probably water deficit happening because we have not had a lot of rainfall. Each of these spikes is a day that it rained. And so this can just tell a farmer as they're going through the season, what is the likelihood that you would have water stress? So what I want to say with these tools is that they are incorporating seasonal forecasts and weather data, and they are not right now incorporating AI data. But what could be is that instead of just having the farmer pick soil type, that you could pull in some massive amounts of AI soil data, and it would give them an even stronger knowledge of what's happening on their farm. Maybe the last tool I'll show you just to see how we could incorporate climate is called Visualizing Climate Change. And this is awesome, pretty cool tool. I'm going to show you Shenango County, New York. If I go back, you'll see that you can look up any county in the Northeast and click on it and get the data. And you can see that average temperature in this county, this is very particularized data. It shows you a statistically significant increase in temperature from the 1951 up to 2023. And same thing, you can look at precipitation data. How has precipitation changed in that county? Also an increase. And then what you can do is look at climate projections for temperature and precipitation and see this is all the observed data. And this is where it's projected to go in the future in this county. Incredible increase in temperature. And so what could we do with this data? Could we start merging this data with the actual on-farm tools to help farmers decide what plants to grow? So that's where I maybe would end with is just these tools exist to some extent. Farmers are using them, but AI could help farmers make better decisions about the best cropping system or soil management practices if we had more of this data incorporated into tools. We could build observed and modeled data into farming decision tools to help them increase their accuracy. And this is one example of a tool that's already being developed at Colorado State by our colleagues with ai-leaf. And it's called a soil digital twin, and it's pretty cool. You can go play around with it. We haven't yet gotten farmers to use this. It's still in development. I want to just also end by saying climate change, there's a lot of climate impacts from using AI. And so I think we also need to balance that. We need to be careful. Yes, AI has a huge benefit potentially to help farmers understand these changes and make better decisions. But at what cost? Are we making sure that when we all use AI or these data centers, that the climate impacts don't outweigh that? Climate change affects everything and all of us, and change begins with all of you. And what you can do, how you can educate your peers, the changes you can make on your own and with the research and the work that you do. And you can also calculate your personal carbon footprint calculator using this tool and see how you can make some changes. I want to shout out to Sophie and to Candace and to Isabella Newlands who helped develop part of this presentation.